All right, well set. Hello, everyone, and welcome to Agentic Hours. So this is our second session, and when anyone's coming back, welcome back. Love to see you all here. Yeah, and thanks for joining us on this lovely Friday evening or morning, wherever you are, or afternoon. So myself, David, and our co-host Subash, we're very happy to host everyone and use this place as a time to network, to meet other fellow builders, and listen on to what's happening in the space. Yeah, so we're happy to see all of you. Sweet. So this is part of AICamp, and the team today's hosting is from AICamp London. So we host regular meetups all around central London, about once or twice a month. So if you're ever in the space, feel free to come on and join. But yeah, more on to what AI Cam is. If you can hop to the slides, Subash. The AI Cam is basically a community that's run all over the world, and our aim is to make AI easy for developers, empower developers to learn wherever they are. Yeah, so we are based in over 50 different countries at the moment, and we're approaching about 500,000 people in membership. So yeah, love to get everyone's location today. That's really cool. So joined by people from many different countries, even on this call. So that's really awesome. Okay, and we're always looking for people to host communities, to give talks. If you have anything to share, please do reach out on our AI Camp Discord or email. And if you have ideas for events or sponsorship, we are more than happy to welcome any of those. Yeah. So once again, topics, sponsors, events, yeah, please do come and look for us. Okay, and on to the next slide, we have the AICamp London team. So again, if you can't reach out via email, can always approach us via any of our channels on Slack or Discord or LinkedIn to reach out to Subash, myself, and we have other people as well on the London team, which are Tibor, Kevin, and Sam. So we're more than happy to field any questions or suggestions. Right. And just a quick shout out again for our community. So we have lots of people on the Slack and Discord channels, and these are the links if you like to join them, but they'll come through on the email as well. And as by AI Camp tradition, we always give this time to let people shout if they have anything. So I'm just gonna have an open mic for 2 minutes to see if anyone has something to shout out. So say if you're hiring, if you're looking for and you want to collaborate on projects, please do shout. So we're gonna go in a couple of seconds. This is our agenda. We have a special guest speaker, Ezo. I'll introduce him in a bit. And after that, we're gonna feature a slightly longer session with a Q&A that people can pop in and ask any questions to a speaker or Subash or myself. And also a time for community sharing. And we will have a trend and nugget session towards the end, and we will close. But I'll give you a bit of a bio of Ezo. Hi. Okay, so I'll introduce him. Ezo is the co-founder of Orra, and he's building a production-ready multi-agent applications. And he's a tech veteran with over 20 years experience at BBC R&D, JP Morgan, and various other startups. And he's been deep in applied AI and deep tech since 2017. So his sweet spot is making complex systems work better, all the way from distributed systems to Kubernetes tooling, and that's been used by thousands of developers. Yeah, so today he'll be sharing a topic which is beyond trip planning or building reliable multi-agent applications. And we are so happy to welcome him for today's talk. So on to you, Ezo.
Hey guys, yeah, it's a pleasure. Thank you. That was a good intro there. Thank you very much. Right, so like David was saying, beyond trip planning, building reliable multi-agent applications. So when you first sort of check out the first example of running a multi-agent or building a multi-agent, the first one that comes up is the trip planner, and everybody gets really excited and they build one and they get really, this is really great. You know, I just built my first agent and I want to do more. And then slowly but surely sort of reality kind of hits. So it's kind of like the journey here is how can we go from trip planning to kind of running really complex agent applications in production where things matter that when you built a trip planning application, things didn't matter as much. So a bit about me, you can get in touch with me in all these places, so on LinkedIn or on Twitter or just by email. Like David mentioned, I'm founder at Orra, and we are essentially trying to make AI agents work in production. We have some open source tooling, which I'll go into a bit later, that we just literally soft launched today. And I would love to get some of your feedback. You know, we're all learning here, so if anyone also has any pointers that anything I missed, you know, please feel free to tell me. Yeah, so without further ado, so there's 100 million multi-agent crews running right now using Crew AI. I think it's probably more by now. But everybody, the first thing they say when after they hear that is like, but AI agents are useless in production. And the reasons they cite is that the fact that they're completely unpredictable, they're quite expensive. More than often, they're quite slow. Users are waiting for like 10 or 15 seconds to get any reply from anything. There are a lot of single points of failure, and you have your crews and your agents, and if one goes down, everything else fails. For developers, a lot of them are, once they get beyond the basics, they find sometimes it's hard to use, hard to reason about, and there are also like way too many frameworks out there. Essentially, there's like I think there's like a framework for every language now, and there's like a framework for every provider, and it's just getting a bit very complicated and a bit foggy. And the most important thing as well, after all of that, is like it's really hard for agents to handle real world interactions. And what I mean by that is that, you know, making transactions that handle some banking element or some payments element, or dealing with some actual, not trip planning, but actual real scheduling. Those things are a bit complicated for agents. And a lot of developers are building infrastructure to kind of work around that right now. Any questions or any insights or agreement, disagreement?
Yeah, I think there's lots of frameworks, and some are a bit more complicated than others. Some can be quite bloated, some are quite simple, and it's moving quite fast. So
yeah, it's moving quite fast. That's true. Yeah, there's a new one every day, actually, almost. Like, I dread to check. Right. So yeah. So
yeah, last session we have covered basics, and we've shown a graphical image of how this landscape is evolving.
Yeah.
And there's a lot of tools, and people get into the tools analysis paralysis. So it's good to call out that there's a lot of things are changing. So nobody's expert. Everybody's trying to create a toy and making it as like a real product. We are in that situation. Yeah. Thanks, Ezo, for covering it.
Yeah, that's a quick question.
Yeah.
Sorry, Larry, you had something to say.
Yeah, actually, can you hear me?
Yeah,
absolutely. Yeah, man.
Yes.
Oh, great. Yeah. Hey, everybody. Glad to be here. I've been trying to chase this little monster down. And it seems like there's two views. There's the enterprise for agentic items. And then there's also just, I guess, mid to lower level businesses. And I look at both of those. Like I was on one last night. They were talking about the agentic stuff, dealing with AWS and so forth, and also with Copilot. And it's a different scenario compared to the smaller clients like mom and pop shops that I run into. But yeah, you're right. I can't wait 5 years from now. We probably won't even be talking about this. Everything's going to be done automatic. So anyways, but yeah, glad to be here.
Yeah, absolutely. Yeah, hopefully we'll have a hand in changing as well. So that's it's like you just said. Actually, that was a good segue. So a lot of agents start really simple, right? The first thing they want to do is you can just hey, let's build an agent that can tell us something about a product or something, and everybody gets really excited. And a lot of these are typically a single prompt, so they're kind of not really using a lot of sort of true agentic flows. It's just they're prompting an LM, or they're just basic tool calls. And like you said, actually, these are really good. What Larry said, basically, they're semi-predictable. They're easy to work with, and they're quite cheap to run and to kind of experiment with. And that's really a good place to be and start. And the code also looks very simple in that case. It's very simple Python code or whatever language you want to use. There's a simple prompt and it does something, or you can have 2 or 3 tools, and your tool calling chain is very easy and just works. And if it fails, it's actually predictable. It's very easy to understand how it failed and what you can do to fix that. And then it can get a bit more interesting, and they can get a bit more complicated. So your agent now has a bit of it kind of understands more about the customer, the sales agent. So it's got maybe a RAG pipeline of some sort, or it's just talking to some databases. And it understands more about what you've been buying recently. So it's got a bit of memory and a bit of access to some API calls to figure some things out as well. So in this sales agent query, can I check for jeans that match shoes purchased to arrive on Friday? Essentially, the agent could be a series of prompt chains that are working through these different scenarios, like get customer details, find weather for a location, find traffic data, just trying to figure out when this thing can be delivered, and just doing some calculations, some basic calculations. So in this instance, you're slightly out of that simple use case. You need to think about a bit more about evals. You need to worry a bit about latency. You need to also understand what is your cost per question, as in every time someone asks this question, how many sort of LLMs are being called, or or even if it's just one LLM, how many times that one single LLM is being called by every customer, because it can get a bit expensive. And you also need to start gently worrying about sort of just one more try calls where the agent the LLM can't really figure out which tool to use. And it just keeps asking itself, maybe I'll try this one. Oh, that doesn't work. Oh, maybe I'll try this other one. Maybe it doesn't work. So the code is still kind of, in this case, it's kind of simple, but slightly more complicated. You can have a big prompt in this instance, and the prompt. The good thing about having a really big prompt is that you can state all your requirements in that one big prompt, and you execute, and you either get your answer, or you don't get your answer, and that's it. And so if there are any problems, you know exactly what's going on. But at the same time, because it's a really big prompt, it's very brittle to debug. So if there is a problem and you need to go and fix something, it's quite hard to figure out what English language features you need to change to make sure that the prompt or the LM behaves in the way that you want it to behave. And you can also go down the tool calling route. Like I mentioned, you have more tool calls now. So you're doing function calling in this case, but you've got more functions that have to be called. So the LM also gets a bit slow because it has to think about all these different function calls, and especially if some of them are quite, hit long, expensive processes. Are they going across the wire, getting some information from an API or from somewhere else? So it's still kind of brittle, but in a different way, and it's a bit sluggish, and you still have to worry about different things. And like I mentioned, evals are still a thing that you have to think about in these two use cases more than the first one. And if you keep going down that complexity, how would you you don't want to keep going? You want to do something. You want to okay, it's getting a bit complicated. Let's do a redesign, basically. Let's refactor this code a bit. So one way to go through that big brittle prompt chain is to break it down to that big prompt is to break it down to a bunch of chains. So you can have smaller prompts, each of them sort of designed to kind of answer a specific question, and then you would have some code that just takes the results from all these prompts and then sort of aggregates it to find an actual answer. But you now kind of increased your bandwidth for hallucination because you have 3 different LM calls that are different. They might be calling different LLMs. Also, if you want to change your LLMs in the future, if you want to go from, I don't know, and this actually happened, going from a GPT-4o to like an O1 mini or something, then you really have to think about every single prompt differently, and you have to have tests that check that each prompt is actually running well in production, because you don't really know what's going to happen. So a lot of people, what they do is they have unit tests that check each prompt like 100 times or 1,000 times and make sure that they average out an 80% sort of success rate, so that they know, okay, this prompt is now legit and we can actually use it. So there are things that you have to worry about in this use case. If you decide that you don't want to go with a prompt chaining sequence and you want to go with an agent crew, obviously you have a lot of libraries that you have to think about, like we discussed, or you can do it by hand, but there are things that you might have to worry about here. Now you've taken that prompt, have multiple LLMs with perhaps some memory in the middle that they're thinking through, and you'd have something called a planner. And the planner would take any request and plan across the different smaller agents in the crew. And the planner has to also aggregate the results, but you have multiple points of failure here because, again, remember that you're using LLMs, and the planner could hallucinate, come up with a weird plan that doesn't actually make sense. And then that weird plan gets executed. Meanwhile, the inventory agent decides that it wants to do something different because, it's also hallucinating. So a way around this is people sometimes introduce a critic that sits in the middle between of these to kind of double check and recheck that whatever's happening is correct. And that's a good design pattern, but the problem with that design pattern is that you are now also increasing the number of LM calls. So like if you have users or someone waiting for an answer, now everything's just going to take a lot longer. So this design pattern, like the agent crew, is actually really good for sometimes like long running processes, or like something that just happens in the background that people don't interact with. It's not an interactive process, but sometimes you might have to use an interactive type session. So you just need to be aware of what's going on. Also, you've increased the unpredictability of the system. So you have to worry about that. And you have to understand, because sometimes the agents might not do the job that they're been assigned to do. They might just go off on a tangent and do something completely different. So your reliability, system reliability, has just gone down significantly. And the last thing is that this is a single node, so a single node failure here would bring the whole operation down. So if a customer agent goes down, the planner would go down, the inventory agent go down, the delivery agent go down. So it's a very fragile system in that sense. So everything cascades really quickly. And remember, this is a mid-complex solution. This is not even a really complicated solution. So let's go forward. So what if it gets even more complicated? And now your agent is like handling payments. So people are not just asking for queries about products and things. They're actually say they want to buy things and they want to buy them, at a specific time or matching something that they've seen before. And the agent has to work through all these things. So if you use the crew, it has to deal with this. And if you also use the prompting scenario, the prompt chains, they also have to deal with this. But actually, no framework that I know of yet, or maybe I'm wrong, can actually help you deal with this. You're kind of sort of a bit on your own here. You have to figure out what to build because you're now going into like more of a distributed systems type problem rather than just an agentic type problem. And you have two issues here. You have an agent that can reason for itself and change what it's doing. And what people have done is use things like LangGraph and similar tooling where they build like a deterministic flow and they just hook into one or two sort of agents and expect the whole thing to work. But then there's a lot of work that needs to sit on top of all of that to make sure that things are still going in the right direction. Is that clear? Are there any questions or?
Yeah, I think there's a couple questions in the chat. Saif is asking about the probability of why you can hit the exact answers come out each time. So his question, I'm going to repeat it for you, is sure. If for any given model, if there's no temperature, then why shouldn't it just give the same output every time? So why is it like 80%?
Sorry, I don't understand the question. Sorry, what was the what was the question again? So if the model temperature is 0 and you expect the same answer to be coming back every single time, it might still be the wrong answer. It's still not the right answer. Does that answer the question?
Yeah, Saif?
I think it's meaning that even if temperature is set at 0, you can still get fuzzy output, right?
Yeah, absolutely.
So it doesn't guarantee it.
Yeah, it doesn't guarantee that.
I just sorry to interrupt, but I just want to add this. I was just typing in the chat. Like it depends on the model training and a lot of factors involved in it. But basically, temperature is an overlay. Like, how do you want to finally call that? So those factors has to be considered. Like, if temperature is 0, then you have to think of like what's the model we are using, or what's the parameter contest, and all these factors comes into picture. Sorry, I just picked you, but I want to add that point for this discussion.
Yeah, absolutely. Thank you. That's great. Yeah, it's really nice. It's more of a discussion than just going off on one. So then essentially what kind of this prompt is like a bit of a rethink. What can we do here, like that can help us sort of move beyond just, like you just mentioned, like toggling different temperatures and writing even more checks, and like writing even more evals, and everybody doesn't, and people use platforms like LangFuse to watch what the prompts, like to have reviews of all the actual answers to all the prompts to kind of check that everything's on the right, it's all good. And the other problem that you also have to worry about is, like, if you're embedding these agents in an existing application, then how are they, like, what's happening to that application? Are you actually, because not the entire application isn't written with like agentic use in mind. So even if it's hidden behind an API, your agents are hidden behind an API, so they have an effect on the other application that's trying to get a bit of work done. And so that's something to kind of bear in mind. And the problem here is you have essentially intelligent cognitive software that is now bound to deterministic software, and the two have like almost like a mismatch. Like, they're kind of hitting against each other, and they're trying to work together, but it's like you have to like add a lot of interim work to make sure that they just like hold hands and like be happy with each other. So this is something we've hit in some of our work, like last year. And we were building essentially exactly this problem. We had like agents that are thinking for themselves and semi-autonomous, and when you had an existing system that did its job, and the question was like, well, what can we do to make them work together all the time, so that we know that whatever happens, we're always doing the right thing, so that even if that we check later, we can actually predictably understand, okay, the solution wasn't deterministic, but we got there in the end, and these are all the steps that had to happen for us to get there, because the agents figure things that we wouldn't know about, essentially, in the beginning of the process. And yeah, this rethink essentially resulted in Orra, and it's essentially like, I call it the missing glue layer, because and the idea is that you need like a layer that sits between, like, that kind of understands that it's living in it's like new type of agent infrastructure. It's living in this new world where like things are not deterministic anymore, but there isn't, and things but still need to get done. Like, even though the world is non-deterministic and you don't know like what's going on at any time, but there is a job that has to complete at the end, and we need to make sure whatever happens in whatever way, that we get there. And the core features of this concept is, well, it's the one core feature is by using sort of pre-evaluated execution planning. So if you guys remember, I talked about, before I show you Orra, I talked about this concept of a planner here. So this concept of a planner is, it's not unique to agents. So robotic systems also use this. They have planning systems. and they've been doing it since like, I don't know, 1998 or something. So it's been going on for a while. There's a language for this called PDDL, which is planning domain definition language. Like literally, like this is something people have reasoned about and thought about before. And the idea with PDDL is that you want to make sure that if you create an execution plan to a specific domain, that before that thing runs, it can be validated, because the real world is a big unknown, and you don't know if, like, you want to make sure that the thing gets done, however it gets done. So people have been thinking about this in a while, and essentially we kind of leverage that thinking and use some papers to do with LLMs. There's the original one was LLM compiler, and it was to do with like making sure that your tool calls, instead of having the LLM constantly sort of reason about what the next tool call should be, you have a planner or something that sits ahead of it that just generates an execution plan and just calls all of those things in parallel, so that the LLM just makes one or two decisions, and it's just got a plan of work, rather than having to constantly reason or reason about what function call should happen next. So Orra simply leverages all of that and gives you guarantees that you get with other systems, like durable execution. And we help you to take some of the tool calls that you might have as function calls, move them out and chuck them into services, so that you don't have to, basically to get more speed, so to reduce the latency and also the cost. And give you like some tooling to be able to revert things when things go wrong. Obviously, you can only revert so much, so we also understand that. And it's domain grounded, so we ground the LLM calls, our execution planning LLM calls, in a specific domain that developers set and reset, so to make sure that it kind of works. So any questions before I think the next slide is a demo? Oh, sorry, no, it's not a demo. Sorry. So actually, before questions. So here's basically, it's really simple from a developer's point of view. You just register with Orra. It's you can run it self-hosted yourself, and you just tell it what your service or what your tool does, or what your agent does, and tell us if it's revertible, the operation that you want to do or not, and give us an on-revert handler. And you also give us another handler that can handle tasks, and we look after that execution for you and make sure that whatever happens, it finishes. And if it doesn't finish, you have full visibility on what went wrong. We do that for Python as well, so it's same sequence. And for Python, we use Pydantic as well to kind of make sure that the inputs and outputs that you define when registering your service are quite clear and type sensitive, so it should work quite easily. Now, any questions? Sorry.
Yeah. In the chat. Okay, Johan says very nice with Pydantic. And he's also got a comment about unit tests. So
okay,
maybe like evals in a sense. And his comment is like, because in traditional unit tests, you test on one thing, but here we have so many different prompts to test. So if you're testing like lots of different prompts, you might not actually get the exact same coverage of 100%. I think that's more a comment than question.
Yeah, absolutely. And you have to be comfortable with that as well, because you have to understand what that means for your domain if you're not getting 100%, because there's a reason people try and get 100%. But you have to think about this in a different way as well. Like in the real world, when you're building big, like proper, like real systems, you aim for 100%, but you never get 100%. So even though your test suite is running at 100%, there will always be bugs. It's not that 100% actually is really 100%. It's just something to be aware about. Right, so I'll jump in a demo really quickly, just to show you what Orra is. Like I don't know if I mentioned it or not, but Orra is actually open source. We just literally soft launched it today. So bear with me if there are any bugs or something. Just please let me know, and I'm very happy to help. And you can see that David contributed to this in the past as well. So he kind of experienced how it works. It's essentially, we have a control plane, which is Orra here, and you register your things with us, and we make them work. So what does that actually look like? So we talked about the sales agent. Imagine if you do actually have that sales agent and you want to ask it some questions. So this is our imaginary sales agent, and I'm interested in this product. When can I receive it? It's a Peanuts collectibles watch. So in this instance, this is going to call Orra with an action. And what Orra does is analyzes the action, tries to figure out what components of the system it needs to be used. These are the ones that you registered using the SDKs, and it processes them and then returns the answer back using a webhook callback, and you get the answer that you wanted. It looks really simple here, but actually how it works is we have a CLI, you can go and check what just ran. So this ran now, and if you can inspect that to see what actually happened. And you'll see that these three services were, well, we call them services, but like one of them is an agent. So you have a delivery agent, a customer service, an inventory service. These services are normally what would be tools in a tool chain, but you've kind of forked them out because they don't need to be part of the tool chain because they can be on the side. And Orra's execution planning kind of takes care of calling it for you. And you can go deeper to understand what actually happened with this. So the inputs and outputs. So you'll see that part of our execution plan is we found that there's some customer data. We took the customer data and we gave it to the customer service, the inventory service, got some product description, and we got some data back about the product. And the delivery agent needs to figure out how to deliver a product from a warehouse to the customer's address, and it's got all the relevant information there to do that. So some of that information came from different tasks, and it executes that, and then by the end of it, you get your delivery estimate. This is, it's quite nice. And like I mentioned, we use this concept of domain grounding. So like we want to make sure that like you're applying stuff in the correct domain. And what that means is we allow developers to create a document that looks like this. It's just a use case, a bunch of use cases for a specific concept that they're running in their own application, or like an example an example action, and what kind of capabilities you expect to happen when this action runs. So we don't know, you don't want to mention what services because that's dynamic, or what agents you have in the system. It's just like, I expect these capabilities to exist in the system and for at least 90% of them to be executed. And what happens is that if you apply this grounding, which I will do right now to Orra, is that from there on, every execution plan we create is pre-validated before execution. Without grounding, what happens is that the execution plan just does some nominal checks, but with grounding, we do more domain context sensitive checks that around, like we use a lot of latent space checks, and we also, so using cosine similarity to see the capabilities are being matched. And we also use this thing I called before PDDL. So we generate a PDDL plan that does that checks the event flow of the system to make sure that this execution plan, when it actually gets executed, it will actually be correct. And if it's not correct, it will error and say, hey, we can't execute against this in your system because you don't have your services aren't wired properly, or this execution plan that was generated by LM actually was incorrect. So we don't trust it. So please ignore it, essentially. And let me just apply the grounding. Oh, sorry, my bad. Grounding. Right, so it's applied. So now if I go back and run that same. So what's happening here now is that Orra is analyzing the request. It's using the grounding data and ensuring it can run the plan. It's quite fast. I think I've already run one before and it was cached. And because we use grounding, you're guaranteed that it should run. Another thing that can happen is that like we can kill this delivery agent and again rerun the whole process again, and the system will pause. So like I mentioned, all executions are durable, so they will always work. So Orra is clever enough to know that the whatever is running right now is going. It's actually checking. Yeah, it's not healthy, so let's do that. It's processing. I've run too many examples today. It's the last one, actually, I hope. And then that'll be it. So you'll see that the delivery agent is paused because we know that it's down. And we just ran everything else and we're just waiting for the delivery agent to come back. And if I bring it back again, then the system will understand that, hey, the delivery agent is back. Let's continue this execution plan from where it was. And let's see, make sure it's running. It's paused. It's still waiting. The pauses sometimes take a wait, and it takes a few seconds for it to kind of go back. If it's yeah, it's processing, and then so it's waited to see what happens, and it's continuing on, and now you have the answer, and it's complete. What we think about with Orra. I'm gonna stop screen sharing now. Oh, sorry, actually one last slide, I think. Let me just see. Yeah, go there. Right, so that was Orra. And if you are interested in the project and you want to contribute or just start it, like I mentioned, it's just hot off. It's just hot off the press today. There's a QR code to get to the project. It's open source on GitHub, and you can always email me or get in touch with me on Twitter or by email, and I'm happy to answer any questions and happy to help.
All right, that's really awesome. Thanks, Ezo, for a really nice slides and also a demo. There are some questions actually
Okay.
on agents. So AZ, he's asking about your earlier demo.
Yeah.
In particular, the agents. Are all the agents running in parallel? Maybe you can break down that.
Yeah, so in this case, they're running in parallel, and you'll see that they're here. They're all running in parallel, but with Orra, what you can do, you can still run them in one file if you like. What we do is we use WebSockets to talk to. So every time you wrap an agent, even if it's a single file in one of our handlers, which is like about 10 lines of code, we wrap that in sort of a little envelope that's powered by WebSockets. So even if things are running on the same file or process, we can still talk to them separately on the side. Obviously, if that process goes down, then both your agents will go down. But it's good for prototyping. In production, you can run them wherever you like.
Yeah, and I saw Subhash answered the question from Chusin. So there's a discussion about structured outputs. And I see you using pedantic here, JSON format.
Yeah.
I think Subhash has also suggested other formats like XML, YAML.
Yep.
That might help as well. Don't know if you have any other thoughts on like structured formats.
Yeah, obviously the issue with structured formats as well is that LLMs can sometimes not send you. So some of the errors that might come back is that the LLM just generated a response not in a structured format. So I think there's some Python's got a lot of libraries, some of them that help you sort of work around the fact that you might not get a structured format and just try their best to wrap it for you so that they do a best they try their best essentially, and then if they can't do it, they error. So yeah, I think you might have to write some of your own code. I write a lot of my own code to kind of handle that sort of situation, and retry again afterwards. You can also do back prompting, which we rely actually a lot in Orra. So sometimes when you get a lot of errors, is that you can say, okay, I'm calling you again, but last time I ran, I had all these issues. Can you, next time you generate an answer, please look into these issues so that they don't occur again. And that, like about 90% of the time, that actually fixes things.
You need to ask a specific specific to LLM, like what's the structure, and you can give an example as well if you want in a specific format. This is the kind of format I'm looking for. Some of the tips, what I see,
yeah. And when you give an example, sorry, go ahead.
What if I want a picture as a format, or something that is not a JSON?
Good question.
It does try to give. It does a good question. It does try to give, but not exactly like if a picture of an Excel format, if a picture of a JSON file, then it try to understand and give you that format. But if a picture of something like a real picture, I'm not sure. I haven't tried it, so maybe Ezo, you have any
I
thoughts?
think, yeah, I haven't tried it as well, to be honest. But I would imagine that you'd have to. I'm sure this is not the first time someone's asked that question, but I'm sure there's a library somewhere that checks that the output that you get back is a specific image of some sort, like, I don't know, a PNG or a SVG or something. So you can do like a format check. But I think, yeah, I don't have an answer to that question. Unfortunately, sorry. It could also be like an audio file, right? Or like it's not just imaging.
Yeah, maybe because in the future maybe the people want the agents to generate other modalities. Yeah,
it's evolving. I think there should be definitely answers for that if you're able to search it. Yeah, some other people might be doing in the similar fashion, trying to find out what could be the other optional formats and structures it can generate. Yeah.
Yeah, maybe some input on that. But again, it's like changing very fast. I do use some Imagen as well, and you can force the output as like a Python byte format, and then check for that. So that might be a way, because sometimes the output fails and you get an error instead. But if you check for the type, that might help.
You can also generate SVG, right? Which is it's XML. So that's actually good, because then you can check the format of the, like, there's a spec you can check against it to sort of see like what's coming out. Does it obey like the SVG format? So that could be interesting.
Yes, and yeah, Johan said SVG. SVG is basically text. Yeah, that's right. Okay, so we're gonna have just a couple of minutes for open mic session. We're running a bit behind time, but that's all cool because got a really awesome discussion even between the demos as well. So we just have a couple of minutes for someone who's a brave soul, or want to share, or want to talk about their experience in agents world. It's open mic time, and we're here to discuss.
So let's say if you have one error in the first step, it's gonna carry down from the second step all the way to the final step. Then how do you do it? Like, what are some approach that you do to make sure that the error doesn't accumulate, because the LLM doesn't know there's an error and it just keep going?
I think let me take this question. So this is called getting into the loop, okay, or getting that's a failback mechanism or kind of guardrails. You have to put it in place. Like if there's an error, you have to make. This was a question keep asked to me when we are doing a real agent development. Like agents goes into loop because particularly when you embed this reasoning model or ground this reasoning model in it. So you have to have a failback mechanism or something in place. So to make sure that every LLMs, or you have to use the routers or the patterns, kind of patterns, so that it will fall back and do a proper reasoning or the next steps in order. So you have to define it. You have to make a definition very clearly on your algorithm. Otherwise, this is very common in agents. Very good question, but this is very common. But I leave for others to answer those questions. Yeah.
Yeah. So Johan has his hand up.
Thank you so much. Thank you very much for the demo. It was very nice. I had a question more on, I guess you have a lot of customers which are want you to do agents and so on. what's the common, what's normal for your customers to ask the agents to do? I mean, what's the typical case? Is it building RAG solutions, or is it? Could you elaborate a little bit on what you see as trends, basically?
Yeah, I think RAG is quite big, but I think it's really hard. And I don't know why everybody is so excited about RAG, but I mean, I understand why, to be honest. But so yeah, e-commerce is a big feature as well. That's why I use that sales agent example, because a lot of people are building sales agents because in e-commerce, you need a lot of support, you need a lot of just boring work that an agent is really good at when the agents work. But also, like, people are moving more into like handling payments. So yeah, it's getting more interesting actually in the agent space.
But it seems like it's mostly for support then, even in payments, I guess, that it's for helping reducing the number of customer questions.
There is a lot of support. Yes, there is absolutely a lot of support. Okay. But support is actually not as easy as you think it is, because you have to answer the question correctly, otherwise you get sued. So it's also quite complicated. And you need to, yeah, it's interesting. It depends on what you're supporting, I guess. Like, are you supporting a financial company that's doing its work, or are you supporting, like a very simplistic thing, or like, a booking agency, or, flight scheduling? So it just depends what you're supporting.
Got it. Thank you very much.
Yeah, Subhash, you have your hand up.
Yeah, John, that's a great question. Typically, customer support comes in as a friend, but AI agents are still like, I work for a couple of customers, so still like we are working in the back end. It's mostly used for the augmentation part, not giving the full autonomy of certain things. Yeah, supply chain and legal, all this. There is some comments like summarization. Yeah, most of the agents is like research to find out something for in the internet, or kind of perplexity kind of stuff is what happening. They figure out all the data, what is available within the RAG. So within RAG, it's agentic RAG now. Then you have tool calling to search the internet and all these things, and you accumulate the data, you understand the context, and you give a summary of kind of data analyst kind of roles. Or they are using a small pieces, but not in a broad space. Everybody is trying to make it scale it. Scaling is the biggest problem in agent operation. Making it operational is really challenge. So these all needs eval and monitoring and all this in place. So yeah, the customer support is one thing, as Ezo said. Yeah.
Got it. Or I hope I got it. Could I just answer if I understand it correctly? I'm going to call this internal tools. Instead, it sounds like you're using Agentic for kind of finding a lot of information in a lot of documents, which helps you and so on. If you were to, is it like 50% is support and 50% is internal tools, or is it like 10% of? I'm just trying to get the trends here.
Yeah.
Basically.
Yeah. So it's a case by case. Okay. So not every customer has a similar kind of a situation. It's a case. If you talk about the product company, they have, depending on their product and business use case, the agentic architecture will define. Okay. So it's a case by case. There is no definitive answer, but where is the possibility of using agents? It could be internal or it could be external, but external, as Ezo was mentioning, like it has to be well handled. It should be in a very clear path. Like how do you put the agent in front of customer is where you have to take a lot of cautious steps. Internal is fine. Still, if it's not working or if there isn't, you can still rectify it. But external facing is really hard thing. I had a couple of experience of external facing. If it does one mistake, it depends on industry. If it's a highly regulated industry, then you are sued. Yeah.
Got it. Thank you.
Okay, and maybe you take one last question from AZ in the chat. It's on Orra, and then gonna move on to Subhash's nuggets. So his question is, I've trained some agents for customer service, but the agents are struggling to follow the policy and the prompts. system prompts. So how can Orra force these agents to follow policy and system prompts?
I'll be happy to meet offline of the meeting, and just give me a ping, and I think we can have a talk about what your problem is and how maybe we can help. Because I need to understand the problem slightly deeper than following policy. Because we don't force the agents to do anything. We're high level up. We just make sure that they operate in the right way. But you can do something. So maybe I'm happy to have a chat offline.
Okay, really awesome. So you can find Ezo on his LinkedIn. But if any questions as well on Slack or Discord, I'll be happy to forward them over. And yeah, we can go on to Subhash, who will have his segment now. Go for it.
Yeah, thanks, David, and thanks, Ezo, for having a great demo and giving us some insights on what you guys are doing. So every session we have the agentic nuggets. So what we try to do is we capture the relevant and very important information and articles or something like that we should know, and we keep it like 3. So for today's session, it's like we have 3. Ezo has covered a lot of things. To connect back to that, it's very important to understand, start with the agent leaderboard. It's in Hugging Face. Galileo has this. Okay, it has been recently updated. So it's always when we have an agent, it's grounded with LLM, and LLM has it in the backend. So when we start with an agent, people start with they have a confusion like trade-offs, or a confusion like is it like cost, efficiency, performance, and all these things comes into picture. So you can use this as a bookmark this, and you can use this leaderboard as a handy thing. Like depends on, this is again case by case on what your use case, what's the problem you're trying to solve, what's the purpose of your agent, and what it needs. I've seen like people try to bring in a big LLM, which could be done with a small SLM model. So you can go here, you can use these things, and you can get proprietary or open source and all this. And this is pretty, I use it most of the time. So I just want to bring it to this table to everyone here. So it's there. We will send you the presentation or a PDF format. You can access it, and that's the first one. And Ezo has covered like how the agent should be built and all the things. So if most of the people joining today has attended the first session, I believe. In that we have I have given a walkthrough of how to build effective agents in a short. So what a LangGraph team has did is like they did like a kind of building effective agents, taking this article, and they shown it how to build it in LangGraph. So it's a 30 minutes video. It's here. So it's a 30 minutes video. It's here. You can use it like really good. You can use it as a reference for your agent development. So patterns is very important, that what kind of patterns you're using in your agent development is to be defined in early phase, and it helps you to scale. It helps you to formulate your agents in a better shape. So you can use this video as a reference. It's 30 minutes, really worth to watch. It gives you an understanding of how to build an effective agents using those patterns provided by Anthropic. They had given that. So, and most important piece I'm seeing in the ground is most of the evals are taken as least as a pinch of salt, but actually eval should be the primary focus when you build agents, because it's not like RAG and all this simple stuff. What we have done, it becomes simple stuff now, but AI agents looks very fancy, but making it operational and making it in a production case is not easy. So until your eval is strong, until your monitoring and guardrails are strong, then you have that confidence. You can put it internal or external, depends on your use case. So there is a deep learning evolution of AI agents course has been recently launched. This is really pretty good. You can spend like 30 minutes, another 30 minutes. So it's like 1 hour, you get some good insights. So make use of it. It's in the slide, it will be shared. This is the nuggets for this session. Every session we will have 3 nuggets. We will pick the right ones that's needed for the time, and that will be helpful to make the foundation very strong, whoever is attending the session. So cheers for everyone. Have a look, take some time. It will be definitely worth.
No, to say that's really good. It's really juicy nuggets. Thanks, Suresh.
Yeah. And lastly, before we leave, we'll take 2 minutes, scan this QR code, add your feedbacks, because feedbacks will help us to bring in, like today we invited Ezo. So we will invite more and more guests that fits to our requirement, that fits to what's the questions we have in mind. We will try to find the right people and bring it to the session. So this is like a community. We are all learning and growing and scaling together. So just take 2 minutes and fill up this feedback form. And we really appreciate for joining this session. And thanks, Ezo, for joining us and enabling this session in a better way. Yeah. And thank you, David, for hosting it and making it possible.
Yeah, so thanks everyone. I appreciate the feedback if you could, and that will really help us guide the next sessions. I'm gonna stop recording now, and again, this will all be up on YouTube for people to peruse and browse. So really love everyone's support here. Many much thanks for coming on this Friday.